Now we come towards another question. That is, the angle of prism is A and its one surface is silver. Now one surface is silver. Obviously the light cannot pass through that surface. So light ray falling at an angle of incidence 2A. So the angle of incidence is double the angle of the prism, and angle of prism is represented by A. On the first surface returns back through the same path because the other side is silver, so reflection will take place in the opposite path. After suffering reflection, at second silver surface, refractive index of the material of glass will be how much? So, given I is equal to 2A, that is angle of incidence is double the angle of prism. So, from the figure, R is equal to A. Now, just we can look at the figure on the right side. We are finding angle of prism is A. So, the base angle will become 90 minus A, and other angle, the third angle is 90 degrees. That is with the silver part. Now, angle of incidence is shown between the dotted line and the incident ray of light, which is found to be 2A. Now, according to the statement of our question, I is equal to 2A, and from the figure, the refracted light, R is equal to A. Now, we will use the formula for the refractive index, and the formula is mu is equal to sine I over sine R. For sine I, we should compute sine 2A, and for sine R, we compute sine A. Trigonometrically, we will expand sine 2A, which is found to be 2 sine A cos A divided by sine A. So sine A will cancel off, and mu will be taken as, that is, 2 cos A. Now, our next question is a crown glass prism of angle 5 degrees. So, variety of glass has been changed. It's a crown glass prism and the angle is 5 degrees. Is to be combined with a flint glass prism in such a way that mean ray passes undeviated. So, we have to adjust both the prism in such a way that the mean ray that will be, which is passing on one face, it should not deviate and directly it should pass. Now we have to find the various parameters. A part is, we have to find the angle of the flint glass prism needed so that deviation must not be there, and B part is the angular dispersion produced by the combination when white light goes through it. Refractive indices for the red, yellow and violet are being given. That is, mu for red, mu for yellow and mu for violet is being given. These three values are 1.514, 1.517 and 1.523. What we are finding according to our observation, that is, up to second place, the numbers are same, or it is varying for the third case, but at the third place we find the numbers will have to vary. So we must make the calculation right up to 3 places of decimal. So for crown glass and 1.613, 1.620 and 1.632, that is for the flint glass. So it means refractive indexes for red, yellow and violet is given for crown glass as well as for the flint glass. Now, to solve this question, first of all, we take the formula for minimum deviation. The minimum deviation is calculated, that is for the crown prism, it is mu minus 1 into A. And for the flint prism, it is delta dash is equal to mu dash minus 1 into A dash. So, basically we have to take the difference of refractive index and 1 multiplied by the angle of prism. This fact we have to apply in the question. The prisms are placed with their angles inverted with respect to each other. The deviations are also in opposite direction. Therefore, the net deviation is, now net deviation is calculated by following formula, that is D is equal to delta minus delta dash, and that is equal to mu minus 1 into A minus mu dash minus 1 into A dash. So, from the previous equation, we have calculated this value and we have marked it as equation number 1. And now, A part of the question is, if the net deviation for mean is 0, so it means that we will take first equation, mu minus 1 into A equal to mu dash minus 1 into A dash, because D is taken as 0. So now from both sides, we will get mu minus 1 into A equal to mu dash minus 1 into A dash. And our subject of equation must be A dash, that is the angle of prism for the flint. So mu minus 1 divided by mu dash minus 1, and then put the values. A is given in the question, 5 degrees. Remaining values are also given. So the angle of prism in the second case will become 4.2 degrees. Second thing, we have to find the angular dispersion produced by the crown prism. So how to get this value? Again, we come to the same formula, that is minimum deviation for violet minus minimum deviation for red, and that will be equal to refractive index of violet minus refractive index of red multiplied by A, where A is the angle of prism, that is 5 degrees given to us, and that by the flint prism it should be delta V dash and delta R dash, that is refractive indexes for violet and red, that is for the flint prism, and for the crown prism the value is given above. Then after that, what we have to do, that is the net angular dispersion. So delta is the net angular dispersion, it is the difference of the two values. So we have taken the difference of the two values, we have computed the values, and finally we have calculated it, and it became delta became 0.03348 degrees. So the angular dispersion has a magnitude of 0.0348. However, we are getting a negative number, but we are interested in magnitude, so magnitude has no sign. So the value of magnitude comes 0.0348 degrees. Now we come to the next question. Calculate the dispersive power for the crown glass from the given data. Now mu V is given to us, that is the refractive index for the violet light is 1.5230, and refractive index for the red light is given as 1.5145. Basically, we are finding the fluctuation starts at the second place of decimal, and refractive index for violet is greater as compared to refractive index of red. Condition is that calculation must be carried out at least up to 2 decimal places. Now, first of all, we estimate the mean refractive index, that is the average value. So what we do is we add the two values and divide by 2, that is called the average value. So we compute the values for refractive index of violet and the refractive index of red. After computing, we add them and divide by 2, that comes to be 1.5187. Now we wanted to find dispersive power, that is omega. So omega is calculated by formula, that is refractive index for violet minus refractive index for red divided by mu minus 1, that is refractive index minus 1. So subject of equation is omega. All the values like mu V, mu R and mu, all the numbers are being given to us. So we have to just make substitutions, addition, subtraction and division. So omega is 0.0163 after calculations.